I'm so excited. So welcome to the What is Packaging webinar. I'm going to, hopefully my screen is already sharing. If you cannot see my screen, I have bigger technical problems, I guess, than my computer, so please let me know. If anyone's having problems either hearing me or seeing the presentation, please use the chat box to let me know. Of course, this is being recorded, and so I will put this online and share it for everyone to be able to rewatch or share with their teams as needed. So if you can't stay the whole time, that's totally fine. Just remember, just duck out quietly, so to speak, and check us out on Protective Packaging Consultants. It's propackconsult.com, and you can /resources to get to our resource page. And that's where you find all these after the fact. We also have a second webinar coming up today at 3:30 Eastern Standard Time, and that is a discussion about flat pack versus assembly. So just a very targeted topic. If everyone doesn't mind going on mute, please. I'm starting to hear folks talking. So if you guys want to join, there's also a second webinar today. So again, we're starting. Please put yourselves on mute because it ends up being very loud just because there are so many people on the line. And all right, we're gonna head into it. And for folks that are just joining in, haven't missed anything, just mute yourselves. I'll probably say that another dozen times on this call. So sorry, everyone. You'll hear that like a broken record. Okay, so what is this packaging material, and are there better ones? That's the topic of the conversation today. Please use the chat window to send questions my way. I will either take them as they come or at the end, depending on the nature of the question. My name is Daniela. We are obviously talking about packaging today. I'm a packaging engineer and a packaging consultant with Protective Packaging Consultants. This is literally what I love to do. I love talking about it. I love educating other people about packaging, transportation systems, quality control. I just believe that there's a lot we can do to both satisfy the customer and reduce waste, increase efficiencies in the supply chain. And a major part of that is packaging, just because it also, a customer is expecting their stuff to arrive in pristine condition, but when it doesn't, that's when everything hits the fan. So obviously there's a lot of marketing and branding that goes into developing your product, advertising costs, and it's a shame to lose those because of a packaging issue. So today we're going to obviously talk about packaging. I know that I have a lot of different folks from different industries on the line, so I'm making this a general presentation about different types of packaging, what they're used for, but also how to evaluate packaging and how to look at ways to integrate different packaging materials in your supply chain, how to do testing if you want to do testing. There's just a lot of information. So again, put yourself on mute. If you have questions, use the chat window. We're going to be talking about variables packaging materials, the entire supply chain, just a quick overview. There's a very specific material by material discussion. So for all of the packaging nerds out there who actually care about squishiness of foam and types of boxes, I've got all sorts of fun stuff for you. Obviously common issues affecting packaging, and then I have some quick wins in terms of the future of packaging, things that we could be looking for, et cetera. As a general bit of information about Protective Packaging Consultants, some of you have previously attended one of these webinars. Welcome, thank you for coming again. For those of you who haven't, I'm a packaging engineer and consultant. My job is literally to help you guys improve whatever it is in your supply chain that I can help you improve. I have a couple of other consultants who work with me, but I'm the owner of the business. And if you have any questions, you're welcome to email me directly at propackconsult@gmail.com. You can find a contact form on our website, and you can also, there'll be an email at the end of the presentation. So just send me an email if you have questions. I'm happy to do a consultation over the phone and just let you know kind of what steps you can take to improve whatever problem you're trying to solve. So, all right, let's get started with the cool, fun, mealy bit of this. So, variables of packaging materials. So, I feel like I need to tell you guys about this because I've had people ask me really interesting, can you give me a price for the right kind of packaging? Like, here is my dresser. I want you to tell me how much it would cost to package this dresser. And there's a lot of variables that go into that, and when you ask me that question, I would say, I don't know. I have to ask you about 30 questions in response to your question to be able to start pinpointing what the cost of that might be, what the efficiency gained by that pack would be, et cetera. So country of origin, and sometimes even the region. So obviously in China, there are regions that have higher amounts of factories in production for corrugated, for foams, for fiberglass, whatever it may be. Another example is Mexico. They actually have lower fibrous material costs because foam's more expensive because there's more corrugate production in Mexico. It just really depends country by country, both import and export fees, whether they have control of the entire supply chain, where they're getting the raw materials from, the quality of those raw materials, and then whether they have governmental protections or taxation on that type of material. For instance, there's a huge upset going on in the corrugate industry because cardboard is becoming less and less available in China because smaller businesses are not able to meet the environmental pollution levels, or they're not able to attain the lower environmental impact through their factories that is required by the government. And so those factories are being shut down, reducing the availability of corrugated and cardboard availability in those regions. And so the farther your trucks have to travel to get raw materials to deliver the boxes, et cetera, the more you're going to be paying per ton or per box, however your volumes are working. To segue into volume, it depends what type of material you're looking at, but for some types of packaging material, they have a lot of processing elements. They might have machinery that's very specific to that shape of the material you're getting. If it's human-based versus, and I'll talk about labor costs in a second, but is it primarily like you have to create a custom supply chain to make that very specific, unique part? Or is it just a half-inch thick foam corner that it can be produced in mass? And if it is, they're usually pricing kind of bulk pricing rates. If you're buying 100 pieces, the price is going to be inherently higher per piece than if you're buying 100,000 pieces. But also just producing those types of materials, for a lot of corrugated manufacturers, they can't have downtime. So it really truly depends whether they have the place in their supply chain during their production hours, I should say, to be able to induct your product, the right machinery to induct it, and the amount of time needed to set up the tooling or the machinery to actually make your product. If they have a lot of downtime, they might be aching for your business. On the other hand, if they don't have a lot of downtime but they have good machinery, they could be offering you a deal saying, we'll run your pizza box, we'll run this box because it's this very similar size to another box we make. We'll run it at the same time, so you'll get a cost break there. Or they'll say, we need custom tooling, we need custom machinery. If you pay upfront for all that machinery, we'll make the boxes for you at such a charge, but you have to pay upfront to make sure all of the tooling, et cetera, is, it's not going to be our cost, it's your investment. So that's just, obviously country of origin, volumes, two major players, and then obviously the last two, sizes. It depends the size of your material. If you're making like a very small piece, that's going to be a lot easier to make than if you're looking for large sheets or a very unique cutout of something. I'm trying to make this presentation as general as possible, but for example, there's material called honeycomb. We'll talk about it in a few minutes. But honeycomb usually comes in standard thicknesses. You can get it in thicker material. You can get honeycomb 6 inches, 10 inches thick potentially. But there's a trade-off because no one else uses that thickness of material. It's usually made in half-inch, inch-thick increments. And so for the manufacturer to make a 6-inch thick piece of material for you, that will probably be extremely cost prohibitive for you as a purchaser of that product. But on the other hand, if you can convince them to glue 2 3-inch thick pieces together, they probably have that much more readily in stock. And so instead of having a 6-inch tall or 6-inch deep piece, maybe you have something that works to cover the same amount of volume on your product or the same surface area, but in a different way. And that will end up reducing the amount of manufacturing hiccups so to speak, with that unique size that you need, or larger size that you need. And that manufacturer might be able to offer you a much lower price point there for that quote-unquote unique size. And then the last piece is labor costs. So obviously, different countries have different minimum wage laws, if any. Obviously, you guys have a number of different factories across the world, I'm guessing, since I don't know your individual backgrounds. But usually the price for labor, let's say in Asia, the East Asia market, is going to be much lower than the US. And in those cases, a lot of the machinery that we would use in the US is not used for manufacturing there, and it's made by human labor. And in those cases, there might be a lot of variability in the packaging material being made to spec. Like there might be some variation in thickness or in the cutout. Like if you actually have a cutout to a statue and you need the statue to have 2 halves of EPS foam to meet to encapsulate the product, instead of using a machine or a mold, they might have a human being with a hot wire cutting device actually scraping out the foam to create the cavity for your statue. And so there might be both variation there in terms of the quality of material you're getting, whether your statue fits in correctly or not. And so that might determine pricing as well for you if there's unusable pieces or whatnot due to the human element. But they might be lower for you because you don't have to have any type of machinery built for that type of work. It's just a human cutting out in its own form of artwork there. So I'm going to move on to the next slide. So I just want to, again, like I get a ton of people who are like, how much would it cost to correctly pack this item? And I cannot answer that question right off the bat. I need to know your supply chain. I need to know what country you're making it in, what you currently pay, the specs of your packaging. And at that point, like I can definitely make recommendations. I can absolutely give you an idea of pricing, but it usually depends on the relationships you have with your factories and the amount of bulk, I should say, you're purchasing from those factories at a certain time. And that's really going to impact the cost. So just giving some ideas here. This is just a handful of photos that I found on the internet just because I couldn't use anything proprietary. So these are just some examples of things, machinery or tools that can be set up to manufacture custom packaging. And so, for instance, here, I think you guys will be able to see my mouse. In some cases, dies for boxes have to be created to create the score lines in very specific parts so your box can fold together correctly. If you have a unique shape product or size product, they might have to make you a whole new cutting, a die cutting, I guess in this case, design for your box to make sure that they're able to manufacture this so that it folds around your item correctly. Because you can't just take any box off the shelf. So that even making a piece of cardboard in the shape you need it to might take some more advanced machinery. Molded, thermoformed, extruded foams or plastics, so things that require heat or some sort of chemical or physical change to be able to take shape, they might need injection molders. They might need actual molds. This is a type of tooling that creates blocks to go around electrical components. And so you might need a male-female mold and tooling to be able to inject foam to create the shape you want. And in this case, this is a hot wire cutting mechanism. This could be done by a human. It could be done by a machine. It's much less prevalent in the US, but for products that need very, very custom shapes, curves, etc., this might be the best way to make them. And so you might have to create your own custom wiring mechanism to create the shape that you want. So I'm going to move on to the next slide. Again, if you guys have questions, just let me know through the chat window. I have it up. You guys just can't see it. So this is a supply chain. This is just, again, this is really general. I apologize if I'm giving you information you might know already, but I want to make sure we're all on the same page. So in terms of the supply chain of packaging, most of the people that you're working with to purchase packaging from right now, they're brokers or assemblers. They're probably not the manufacturers. Packaging is a culmination of steps from raw materials to the production of a block of foam, let's say as an example, to the cutting portion of that foam, to the final aggregation of that shipment, to the storage to your facility. Especially if it's a more stock product and it's a standard foam corner or a standard box size, it's like a 12 by 12 by 14. Those are going to be mass produced by dozens, if not hundreds, of manufacturers across the U.S. or across the world even. And most likely you're purchasing it from a reseller. So this doesn't always mean that the cost is higher. So I'll give you some examples here in a second, but the biggest question that I get from that piece of information is, well, can I just go directly to the manufacturer? Won't the cost be lower? And a lot of the cases, the answer is actually no. If you're buying a stock product, you're working with a broker that has a contract. They're purchasing in much bigger volumes than what you need, and so they're actually getting a price break. They may not be fully passing that on to you and using that as their earnings and margin, but for you to go directly to the manufacturer, the manufacturer may not even work directly with purchasers outside of like the 4 distributors that they work with across the world, but they probably are not going to take you seriously with very low volumes. Moreover, they have like very strict production schedules that, again, making these huge quantities of materials you have to slot yourself into, and a lot of times they're organized specifically around the distributor's needs, not small potatoes as they would look at it when they're buying millions of units of a part as opposed to a couple thousand units a year. Like, they're really going to work with those who are able to give them huge volumes. So obviously you're paying for a service in that point, and the service predominantly is being able to work and be the middleman between and the major purchasing agent between the manufacturers and you. So those are the distributors working on your behalf. One thing that I didn't put on this slide, but the packaging industry in the U.S. is it's really small. Believe it or not, almost every packaging company has been purchased or bought or owned by another packaging company. They're constantly doing mergers and acquisitions, and it makes sense in the packaging industry to be able to work with huge volume discounts from raw material suppliers to purchase as a conglomerate. So that's why you'll hear like a certain company was purchased by another company. You'll have to find a new corrugate manufacturer, they're named something else. That happens so frequently, and it's extremely common in the U.S. to have, for instance, like part of an industry bought out by one company. So the examples that I have on here, I bounced around the slides, my apologies, but I just want to make sure I did a little rant there about the packaging procurement side of things. But for instance, if you are purchasing like an L-shaped piece of EPS foam from a supplier, most likely, like if you're going to like Sealed Air or something, so they're purchasing sheets of foam off of a bulk distributor or even possibly a manufacturer, depends on honestly like that day of the week and who has that material available or who they have that relationship with or contract. Going backwards, that party is purchasing raw materials or huge blocks of foam even. There are foam pieces made the size of trucks, like 40 feet long by 9 feet wide. And there's huge wires that are cutting these pieces of foam to the sellers. And so you might have a company making the foam pellets that are used to actually make huge amounts of, depending on how, I'm trying to be general here, but depending on what type of foam you're purchasing and how it's actually made. And so if you're just, you might be extruding the foam, thermoforming, et cetera. Like there's so many different ways to make any type of plastic there, but you could just be getting like in general raw materials from one party, shipping them to another party that creates this entire block of foam. A third party will store that block of foam until a huge order is placed, and they will cut it into sheets that are, let's say, 2 inches tall. And then a third company, or maybe a factory that they work with, a facility, will actually cut out the smaller block to be able to make it into an L. And they'll save both parts because most likely they'll be able to sell the waste foam to somebody else. It's just another piece of packaging material. And so it's kind of this, you've just purchased from 5 different steps in the chain to get a very standard piece of L-shaped foam. It sounds kind of ridiculous. It's like I should just be able to get this from one guy who's like making this in-house, but it rarely works that way. So I'm going to move on to the next slide just to make sure we have enough time to talk about all this. So we're about a third way through the presentation. So I'm going to go into material by material breakdown. And this is where we might have some more questions. I'm happy to answer those. This is very quick information, and I'm happy to give anyone who needs it a more comprehensive or in-depth discussion of a specific packaging material, especially if you can send me photos of that product. I can do a consultation for you, like whether that packaging material makes sense for that product. So going from left to right, so these are the most common, and again, there are so many different types of packaging materials. These are the ones that are the most common in the e-commerce industry for home goods, furniture, small electrics, things that I think most of the folks on this call would be selling or interested in. So that's why I put them on here. There are many more materials out there than these, but these are the ones I think will capture your interest the most. So the first one, expanded polystyrene, EPS. So this is the most commonly manufactured packaging material in the world. Almost every single country in massive supplies, and it's relatively unregulated. Unfortunately, it is not the best material on the planet for the planet, but also, and I'll talk about the forces that act on this material and how this material reacts as well, but it doesn't respond that well to impact, depending on how dense it is. So if you take a sponge from your kitchen and you squeeze it between your fingers will come very close to touching one another because it's not very dense. Foam, there are foams that are extremely low density, so if you squish them, your fingers will break through the foam very quickly, or you'll squish the foam into a sheet that's really, really thin, and then sometimes it'll spring back, sometimes you'll see the indentation. So for the foams that don't spring back, which is usually this type of foam, it can take so many crushes and then it just stays crushed. And it can crush all the way down to a thin piece of paper in thickness. That means it has low resilience. It also has a high fracture rate. So for instance, if you were to put this on a corner, like this specific piece, this corner piece that we're looking at right here, if you were to put that on the corner of your desk and then hit that, especially if you have a sharp corner like I do of a desk, just pop that on the corner. That corner will break through your material. So low resilience, it's very easy to fracture through and puncture, unfortunately. And that's because of the method of manufacture. Usually most foams, most polystyrenes in this case, are made in lower density formats. And so when you think about, let's say a bicycle helmet, the example I usually use when I'm talking about polystyrene, usually bicycle helmets are made out of extremely high density EPS foam. Like we're talking about 6 pounds per cubic foot. In relative terms, the material that is used, the cheap material that you can find from packaging suppliers working with factories, so remember I just said bicycle helmets are about 6, possibly higher density than that depending on what type, if you're purchasing an inexpensive versus an expensive helmet. There are standards on that if you ever want to read them, just Google. But at least 6.0 PCF. Packaging materials, the really cheap ones, are less than 1.0 PCF. And that's why they're so squishy, they're brittle, they're very easy to crush, and they don't have that spring back. So when I perform packaging evaluations, I take a look to see what type of material are you using and what's the likelihood that that material will be able to cushion the product through multiple hits, jostles, when there's weight being placed on that product in irregular patterns, when it's experiencing repeated shocks and vibration in a truck. There's a lot of, there's a lot of forces that are being exerted on the foam, and a lot of times EPS it fails quickly, unfortunately. Definitely cheap, so if you have a very light item, it's a great solution. If you have an extremely heavy item, I don't recommend this type of material. So moving on to this one, Arsol foam. So this is Arsol itself is a copyrighted product. There are very few manufacturers of this. In fact, I'm pretty sure there's one manufacturer and only a handful of distributors. And it's a combination. They actually created this unique concept of mixing these two types of foams together. So a polyethylene polystyrene mix. And so it both has the resiliency of polyethylene, which we'll talk about here in a moment, but it has the feel and texture of polystyrene. So it actually can be made from recycled polystyrene if it is able to be brought back into a facility of some kind. And so it can be molded in specific shapes. It can be made into corners. It can be made into into sheets or whatnot. It's a higher price point than EPS is, but in general, its ability, it has higher resilience. It doesn't have as high of a fracture rate because they're mixing it with the polyethylene, so it's a little bit more spring-like, and it's so much better at cushioning. That being said, it's more expensive because there's limited production, and it's predominantly in the U.S. and several parts of Asia, and I think there are a couple other plants in Europe. If you want more information on this type of foam, I know some of the main players in the business. I'd be happy to put you guys in touch. Just let me know. They do make stock parts. They sell through distributors. It's not unheard of to use Arsol foam. It's actually a really good material. It's just still, in terms of the EPS market, it's like 1% or less of the EPS market in terms of the folks using it in the production of the world. Polyethylene. So this is the really fancy foam, I would say. It comes in different colors. It's generally just like a nicer foam. And if you've ever hit your friends with a pool noodle, or your kids hitting you with a pool noodle, however that dynamic works in your family, that's the material. So it's a really resilient spring-like foam. It comes in a really thin sheet, so you guys probably have used it. Folks have called it pearl silk. Obviously, poly sheeting. There are a lot of different names for it. So these are the same material, just in different thicknesses and different densities. And higher price point, it's a really high resilience. So you could jump on this thing and it's going to keep its shape for a lot longer than either of these two will. So it has a lot of spring back to it. And then it also fractures infrequently. So you can puncture through it, but it probably won't split apart like this one would. This one would split apart on the edges, and you'd have 3 or 4 pieces of foam if a sharp edge cut into it. On the other hand, this would actually stay in place. It might tear a little bit, but it would actually remain in that place. So this is generally more used towards higher end products. So think small electrics, electronics, really things that have higher margins. That being said, it's still difficult to recycle, just as all foams are. There isn't really a reuse option unless you are collecting this and mailing it or taking it to a specific recycler. And most customers are not doing that. They're just throwing it in the landfill, which is really sad because most of these things generally cannot go through an efficient landfill cycle through burning, or they don't decompose for like 50,000 years, something insane. So there isn't a really good way of getting rid of these types of packaging materials, unfortunately. But hopefully, by using a higher end material, you can use less of it and it'll be more effective, thereby reducing the amount of times you have to ship replacements. So there's still less waste in the world. Like, we wouldn't want to throw away a bunch of cheap plastic, or I shouldn't say plastic, EPS, so any types of plastics, polymers, in addition to throwing away the product because it's broken. At least only get rid of the packaging and keep the product because it's not broken. You guys get it. Not going to preach to the choir anymore on that one, but there's also polyurethane. This is much less prevalent in this industry. It's still used, though. The fun thing about it, though, is this is actually used in materials, like in products. So if you get a sofa, if you get a mattress, like this is actually a proponent in different types of furniture. So a lot of the byproduct is actually used as packaging, which is really neat. It allows it to have a lower price point. Also polyurethanes, different types of materials, they can be used in different industries. And so I did want to put into here, like I don't want to talk too much about polyurethane, but in terms of the different materials here, like shrink films and stretch films and tape, like they can be made out of these different types of materials. It's not always one material that makes it, it's usually a blend. And so it can be a combination of like a polyethylene, like a very thin poly bag, and you can get all different types of reinforcements and barriers depending on the thickness and the chemical composition that it's made from. So just kind of an idea there, just not spending too much time on the polyurethane. It's generally not used for impact absorption. So in terms of fibrous materials, again, if you guys have questions about foams, I'm happy to go back to that slide and talk through it some more. Hopefully everyone's still on the line and can hear me. I haven't gotten any chats in the chat window, so if you have questions, happy to wait till the end, but also happy to take them during each slide, just for this webinar. So for fibrous materials, I say fibrous materials because some things are not manufactured like paper is. You don't have the specific packed board or sheets. For instance, molded pulp, it's a different process of being manufactured, but it's still coming out of it's coming and being made out of fiber. So I'm going to just quickly discuss the different types of cardboard or corrugate, and then go into different types of packaging material that are also made either out of the same materials that go into making cardboard or into similar materials. So with corrugate, so if I work with you in the future, I hope we can do so. When I talk about different types of corrugated, there are so many different varieties, and usually with the less expensive manufacturing, a lot of times you're getting a really weak piece of corrugate, especially if you're purchasing like a weak piece to begin with and then it absorbs water. Then there's going to be a problem of it retaining its structural integrity. That being said, to just break down the concepts of making a box or making packaging material. So the first part of this slide, or this column, waiting for my mouse to, there we go. So single-face corrugated, it actually means that you have the fluting and the backing. So you have the paperboard and the fluting. And I have seen this successfully used. It does have a little bit of crush. The fluting itself, it's an accordion, right? So it has a little bit of height. It's similar to the front end of the car. It will crush a little bit. That being said, usually this is a really great way to separate materials from each other. So for instance, if you have two chair legs and you need to wrap them in something, but you also want to add just a little bit more cushion, but you don't have too much space to add like sheets of foam, you can use single-face corrugate. It will probably crush. It can take shape very easily. You can tape it on without damaging your product. Just remember though, all types of fiber, some are much more limited in abrasion ability than others, but usually fiber can be abrasive to your product. So just keep that in mind if you have something with a really nice finish or that you're worried has the possibility of getting some of its finish rubbed off. You may want to use, I'll go back to the previous slide, maybe. My mouse doesn't like to engage when I'm in a presentation mode. You might want to use this and then go to something like this. So just, again, this really depends on the type of product, and I'm just trying to make this as general as possible so everybody can get a little bit of benefit out of this. So moving on to the next one. Some of you I should say, are not going to be using single-face corrugated. Hi, for whoever just joined, please go on mute, and that way we won't have any background noise. Thank you. So we're just talking about different types of fibrous packaging material, and the presentation will be available later on. So please write down your questions, send them over. Okay, going back to this. So you guys can see you're building on the fluting and backing concept. And so once you add another backing, so another piece of paper, essentially onto the fluting on both sides, you have single wall. So single wall means you can actually have a pretty strong box made out of single wall, but you have one layer that something, an external force can puncture. Moving on, if you add another piece of fluting and another piece of board, you have a double wall box. This is the most common box used in the packaging industry for anything over 50 pounds. This is the most common in general because it's cheapest to manufacture. Most factories are using it. It's lighter. Usually if you have a really light product, you don't need a super rigid container. But as you guys know, some products are more heavy, are more fragile, are more dense, and have higher components, so that's where I would recommend a double wall. If you have an extremely heavy, dense product that requires a lot of rigidity, a lot of structure, this thing cannot be put weight on, etc., I would recommend going into triple wall. It exists, it's much more expensive, but instead of adding V-board or trying to add a lot of internal rigid packaging to be able to prevent your product from bearing weight, or if there's any risk of puncture, etc., it's just so much more efficient to use a better board quality than trying to pad it with a lot of different things. It's less material. This is obviously fiber is recyclable, and foams usually can't add vertical structure, whereas corrugated can. So you guys, if you have any questions about different types of boxes, fluting, etc., please let me know. This is a fun part. So just one quick thing about this. When you are picking a box, you need to check the vertical or horizontal orientation of that box and choose accordingly. So I can't tell you how many folks I've visited. I've gone into their warehouses and they said, we can't figure it out. We stack 5 boxes on top of each other and the bottom one crushes. And I take a look at the fluting, and the fluting is running parallel to the floor. And so if you think about this as columns, each of these is a column. And if you go to Rome, I've never been, go to Greece, wherever you're actually going to see different archaic, the ruins, you'll see these columns are obviously vertical. Like if you need a support beam in the house, you're not going to lay it down flat, you're going to put it vertical. And so I can't tell you how many times I've seen boxes with their fluting or their support beams not running according to the orientation that they need to provide support on. And so that's just something to be cognizant of. If you have a really strong box, but you can see the lines of the fluting and they keep crushing and buckling out, you probably have your box oriented the wrong way. So you can either flip the orientation in your warehouse, or you need to talk to your box manufacturer to change how they die cut the box, because all they need to do is turn it 90 degrees and you have a different orientation, a different strength mechanism for your box. So it's a really common solution. This is like a $500 piece of advice. So for all of you who are taking notes, highly recommend writing this down. Check your orientation. It's Packaging 101. And I can't tell you, I would say 98% of the folks that I visited over the past 7 years, they had a problem with their box orientation, and solving that solves probably 50% of their packaging and warehousing problems. So yay for value and education. But if you don't know to look for the fluting, and I'll have examples for you later in this presentation, I believe, but if you can't tell whether your fluting's correct, just take a photo of your box, look at the flaps opening, and see if you can see the flutes, like actually see, you can peek into the flutes. And that way you can actually start to identify how those flutes are oriented on your box. If you still don't know, just take a photo. You can text it to me, email it to me, and I'll help you. Okay, so next one. Spent a lot of time on corrugate, but as you guys know, like almost everything ships in a box, and so boxes are really important. But what can you put into your box? This is where it starts getting fun. Craft paper, not that cardboard wasn't fun, but craft paper can take any shape you need it to, and it can be condensed all the way down to as far as you can pack a wet ball of paper, right? So it can compress pretty heavily. That being said, here are some of the pros and cons to it. It's a low price point, so it's generally really inexpensive. It's easy for workers to handle. It's quick for workers in your warehouse to handle. That being said, it's a one-chance package. So you have one chance of putting the paper in correctly, and then you probably have one crush. If you're using it for immobilization or dunnage or separation, totally fine. But if you have a heavy product, not really the most effective solution, because your product will crush the paper into a flat thing, and it will not cushion. Most people incorrectly, so I wanted actually to use this image and to show you, this is not the right way to use craft paper, even if you're crumpling it, because if you are just layering it, like if you have a piece of paper on your desk right now, instead of crumpling it up, if you roll up your piece of paper right now, and I'm actually doing it as we're speaking, if you roll up a piece of paper from your notebook and then squeeze it together, there's absolutely no impact protection there. There's no cushioning. Even if you start folding that into 6, 7, 8, if you fold it hot dog and sandwich style, if you want to get into real technical terms there, if you fold it into any amount of folds that you want, it still will have very, very limited cushion. Why is that? Because it has no fluting. You're just folding the paper instead of implementing this type of accordion system. Without that accordion system, there's very, very little impact absorption it can offer. Great for mobilization, great for dunnage, void fill, not good for cushioning a heavy product or a corner or something fragile. So moving on to molded pulp, I won't spend too much time on craft paper. Molded pulp is a really great eco-friendly solution if you have the ability to invest upfront into making the tool, or you have something that can fit into a very standard mold that's already been made. So this obviously needs a lot of very unique machinery to be able to make that specific shape. The other piece of it that has to happen is it needs really high ridges. And I should have included something that I could allude to here a little bit easier, but molded pulp, unless it can crush, again, similar to the front end of a car, it's a very hard material. So if you get any piece of molded pulp into your fingers and try to crush the wall of that pulp, just like if you held on to the end right here, you try to crush it, it's like a piece of wood. There's no impact protection. The impact protection actually comes from when this piece moves closer to this piece. And you're actually crushing this thing down because it has a crush zone. So that's how molded pulp works. If you do not create enough height or depth in the crush zone, you're going to have a broken product. So molded pulp works really well if you have a lot of void area that you need to fill and that you have the ability to create those grooves out of. And I actually put in here, built like cars are made. It's exactly how it is. Who knew you were going to get automotive lessons today? So the next piece I'm going to talk about is honeycomb. The cool thing about honeycomb is it is so similar to corrugated in the fact that it also has these little columns. So remember we were just talking about if you go to the Coliseum or whatnot, everything is vertical. Everything in your house is vertical. And so a piece of honeycomb, it's really effective in only 2 directions. And if my mouse comes back up, it's effective on this side. So if you crush something this way and if you crush something the other way. But if you try to crush it the opposite way, it's going to act really weird because there's no vertical, there's no fluting in that direction. You'll just puncture through the sides of the honeycomb, and that's not going to help anybody. So the most common issue that I see with folks using honeycomb is that they're orienting it the wrong way, and they're receiving a lot more punctures in that case, so it's not able to absorb impact. That being said, it's a very high quality material. I love it. I could use honeycomb on pretty much everything and be very happy about it. It comes in limited shapes, so it's really difficult to make like a curved piece of this. Like you have to crush parts of it, and it becomes a curve. In gluing this stuff together, you would generally glue a flat face to a flat face. Gluing it on the sides obviously is not a good idea. You can also split squirt. So if you cut almost all the way through a piece of honeycomb, it holds, the paper holds it on a hinge, and you can use it as an L shape. They can also be made into L shapes. There are different types of shapes it can glue together, essentially. You talk to your honeycomb manufacturer, let me know if you need one. But it's really effective. It's limited in terms of the curves that it can be made into, and the thicknesses. As we talked about earlier in the presentation, like it's generally very common to have standard thicknesses with honeycomb, like a 1/2 inch or 3/4 inch or an inch. It's not as common to have like a 6-inch piece of honeycomb, whereas you could get a 6-inch thick block of foam, no problem. Yeah, so that was honeycomb. Built-up pads are possibly my favorite packaging material that are woefully undiscovered in the packaging world. So built-up corrugate is essentially, and you guys can probably see this, if not, if you have more questions on this, by the way, about any of these, I'm happy to send you better pictures, close-up pictures, and just more information about this. So just let me know. The layers of this are actually just the corrugated material. So you have corrugated cardboard here, and they're layered. And because it's very thin layers of wall and the fluting in between every single layer, they're great cushions. They're absolutely fantastic cushions. They don't get cut through like foam does. There's very little risk that it'll be punctured. Even if it is punctured, you just have a couple more layers of cardboard. So it's totally fine. You can cut into that stuff all day. It's high density material, so the heavier your product, the more I'm going to tell you to either go to honeycomb or the built up corrugated pads. And the best part of this is it's usually made from reuse. So you can have this made out of recycled or refused corrugated material, and it's trash. So it's effectively a great absorber for, hopefully in the future, it'll go into higher production amounts across the U.S. And be less cost. But at the moment, you are able to get really custom designs of this because you're just cutting paper. And you can have blades that do that pretty easily. You can have glue with this. You can fold it into different shapes. But it's not as heavily produced as foam or corrugated is in the industry. So I have plenty of contacts for this. If you're interested, let me know. It is a very effective packaging material, but just very underrated as well. So I just want to talk about other types of materials. And we've talked about some of these before. Just you'll see how we talk about them in just a moment. So I also want to just give you a quick, we only have a handful of slides left, but again, a quick reminder, if you have questions about any of these packaging materials, let me know. I want to give us enough time for questions at the end as well. So I'm going to blow through these. Encapsulated air. So this is a thin bubble wrap. I hate encapsulated air. I hate air pillows. I hate bubble wrap. You're probably going to hear about this if you ever come to me with a question about bubble wrap. It doesn't work, depending on whether it's cold or hot outside, high altitude. If it pops, it's just essentially a layer of plastic. It's like tape, putting tape on your item and hoping that it absorbs impact. Unless you put this beautiful vase into that entire roll of bubble, it's probably not going to be very effective. It's one chance packaging, and it's not my friend. The next one is peanuts. So this can come from EPS starch. This is not a bad packaging solution. It just is very targeted towards a very specific packaging concept. That being said, usually EPS peanuts and even starch, they're very low density. So the heavier your item, the less likely I am to break this recommendation. They're also not customer friendly. Like once you have to start digging around in peanuts and they fly everywhere and they're static clinging to your clothes, they're just a nightmare. So I probably won't recommend this to any of you, but you know, it could happen one day. So, but moving on to the next one, mushroom packaging. So this one is really interesting, really high-end, high price point, and also high density because it's mushrooms, fungus grown into a mold. Sometimes it's a different type of material that's pulpated into like a fungus and corn husk mixture is something that Sealed Air has created. And they make it, they actually pour it into the mold, or it grows into the mold itself, and then they heat it up so it kills off any of the growth, and they make it into a mold. Films, so as I said before, most of these films are made out of things that we talked about before, usually a polyethylene base or polyurethane. Films are extremely helpful with most of the things that we'll talk about. Usually there's a need for immobilization, unitizing components, being able to prevent them from moving. So this is a great way to do it. Also keeping LTL loads or full truck loads from movement if you're shipping like a ton of boxes on a pallet. And then one that I actually answered a couple questions on earlier last week was beadboard, and it's actually made out of paper, so it's also called edgeboard or paperboard, and it is effective, but there are just better ways of using it. There are definitely specific ways to use this. There are a lot of wrong ways to get it wrong, and there are only a handful of right ways to use it. So if you're considering using this and investing in it, or you want to make sure that it's being used, because it's 10, 15 cents per every one of these in some cases for larger boxes, I'm happy to evaluate it and let you know if there's a more effective way for you to be using this type of board. So these are some of the common issues affecting packaging, and I'm so sorry I'm running kind of over into our Q&A, so I'm going to quickly go through these. You guys probably already packaging experts at this point, so if you have questions, I'll take them in a few minutes. These are obviously some of the most common issues, and this is what I was talking about before. So I'm going to talk about the fatigue, and then we're talking about the cave-in, but we kind of went through this already. So this is a great indicator. A lot of times when something is crushed, it usually is because there was mobility inside the box. And any type of mobility inside the box leads to multiple crush points or crush rebounds inside of the box. So it's kind of like if you were to have a concussion, if you have something that's able to move like your brain, sorry for anyone who's squeamish out there, but if you get hit in the head or you have a concussion, you're going to have an impact, you're going to have a blow on one side, but your brain's going to bounce off the opposite side of your skull. And so that type of reverberation is very commonly seen in e-commerce shipments because of the types of impact that it's receiving. And so you not only have to consider like a corner is going to get crushed if that box falls onto the floor onto that corner, but what happens when that corner comes in contact with the floor, force is sent in the opposite direction, but then it comes back down again and potentially over and over and over again. So not only is that one shock, it's multiple reverberating shocks in your products. The second piece of this with stacking crush fatigue, you have the ability, if you have a lot of space in your box, if you have a wet box, if you have a weak box, and your fluting potentially is going the wrong way. So in this case, the fluting is going correctly, the columns are up and down. But in some cases, your fluting could be going this way, and it could buckle very easily. And so those are just common signs in your packaging that you might have the wrong size box, the wrong density or strength box, etc. So these are just some indicators of fatigue. So they're outside-in fatigue. I know that this is information you'll probably look at. Like once you go into your warehouse again, you'll be like, oh, wow, what happened there? Go to a return and go look at it. So you'll have punctures from other boxes. This is most likely another box falling against this one, tearing into it and tearing down with gravity. So you can kind of see where that started happening. And these are photos I got off the internet, so bear with me on these. They're kind of terrible. This is really common. If you use straps or stretch film, especially with textile products or pillows, there's always a chance that your stretch wrap will cut, or your straps in most cases will cut right into your box and into your products. So don't be that guy. Don't garrote your products, especially when you're trying to keep them on the shelf. If you worry about your stuff falling off of your shelf in your warehouse, the right way is to change your warehousing style or the strength of your boxes, not to try and tie them onto your racks, which I've seen. Moisture deeply affects, so you can even see in here, this has absorbed so much moisture. It's just a terrible, it's a weak box to begin with. The weaker your box, the more likely it is to fall apart due to moisture. And that moisture, it's coming from everywhere, right? Like your boxes sometimes are coming across the ocean, they're sitting in the warehouse. There's a lot of moisture to be absorbed, and desiccant is not going to help with that, unfortunately. Desiccant only absorbs to some, to a fixed point, and it can't absorb anymore. And the ocean and the skies and humidity are much more powerful than your desiccant will ever be. Let me know if you have questions about this and want like a consultation on box strength too. That's a really quick one. I'm happy to do it. Moving on to this side of the screen. So there's this thing called compression creep. And I often joke with people like, you don't want your kid's data creep or whatever. Don't let your products go through this either. So products that weigh more, they have more pressure per square inch. And when you start putting that pressure onto targeted points on foam specifically, but also on fibrous materials, they have the tendency to collapse and fatigue. The more they fatigue, the closer your product gets to the ground, but also the more potential there is for movement inside of the box because now the packaging is stretching out, caving in, etc. So this is very similar to what you'll see to like the edge of a table. So if you have an edge sitting here, this cavity will grow and get closer and closer to the bottom here, which essentially means to the outside of your shipping box, which is where it's going to receive impact. So changing the density of your materials, changing the quality of the materials, changing the way that your materials, packaging materials are structured and designed around your item, it's what's going to prevent you from dealing with compression creep and fatigue. I'm actually going to skip this slide. I usually don't skip slides, but if you guys want to talk about cushion curves, it's something what I just said, like depending on the weight of your item and the density, the pressure per square inch will tell you how many G's or the impact going into your item. So truthfully speaking, you want to be at the bottom of a cushion curve, but most of you guys don't work with cushion curves, so I'm kind of kicking myself for putting this slide in, but it truly is like if you have a high-heeled shoe and you're jumping onto a piece of foam, your high heel is going to blow right through it, and that's because of the pressure per square inch. You have too much weight on that high heel on that really small fixed point. So here are the quick wins So these are honestly for you guys to take back to your teams. I know we're going to have very short amount of time for questions, and if you guys have time after 3 o'clock, I'm happy to take more questions after 3. I'm free until the 3:30 seminar, which is a lot shorter than this one. So nothing should move. You need to protect your protrusions, immobilize any doors or drawers or remove them, very similar to nothing should move. And make sure that your shipping labels can stay on your box. Make sure they don't come in contact with the floor. And it's not exactly internal packaging material for structural protection, but you might spend all this money on protecting your product, but if your shipping label can easily peel off or fall off in the transit, your product's never even going to get to the customer, even if it is in one piece. So I just wanted to throw that in so everyone can, you guys, if you have questions, let me know. You can read through all of this. We kind of talked about the immobilization piece, why nothing should move, protecting protrusions. If anything sticks out, like your elbows, obviously you don't want those hit. But these are all things, general recommendations. If you want something that's a little bit more unique to your product, happy to set up a consultation with you, you should send me some photos of your packaging, and then we can go through and do an evaluation where I can teach you the things to look for or make a recommendation that you can take back to your factories to improve. So with that being said, with 2 minutes to go, if there's somebody who has questions and you can't stay after 3, please let me know. You guys are welcome to unmute and ask questions. If no one has questions, I might be a little concerned because that means I've been talking to a bunch of packaging engineers. But yeah, I'm happy to take whatever questions you have for me now. There are crickets. No one has any questions. What about carton density? So this is strength, 250 pounds. Yep, so quick information. So carton density is carton strength, and it's usually 250 pounds PSI. It's usually actually 275 is a common double wall strength. I would say that's the most common for double wall, 200 or 275. The rolling rule of it is if your product weighs more than 75 pounds, you cannot have anything less than a 275 box. If you need to have less than a 275 box because of margins or because you can't get your hands on that box, we need to talk. Because it's most likely that your box, after it absorbs moisture, will not be the right structural protection for your product. And as soon as the box can be punctured, fall through, crush, etc., because of the weight of your product or the way you're warehousing, you're going to have problems. So it depends, A, if it's a single wall, or B, a double wall box. But if you have anything that's over 75 pounds, the standard rule is you have to be at 275 double wall or higher. If you want the equivalent in ECT, edge crush test, I'm happy to send you a graph that illustrates that number system that you can find a corresponding value. Good question. What else? Anything else? I know it's 3 o'clock, but if you guys have questions, you're welcome to chat with me now. I'll answer it before I turn off the recording, and you guys can watch the recording later. You guys are also welcome to just stay after for a few more minutes. Any other questions? Okay, well, hello?
I just chatted with you, but I guess you didn't get it yet. On the honeycomb, can you give me a manufacturer or the pricing?
Yes. Okay, yep, your chat just came through. I'm just on a little bit delay. Okay. And Tiana, I'm just seeing your thing now, so I'll get through that in just a moment. So with recommendations for manufacturer, so again, the pricing thing I can't answer for you. Depends how much you're buying and where you're buying it from and how frequently you're buying it from that person or company. I'm happy to send over some common manufacturers, kind of the big boys in the honeycomb industry. The thing that you need to look out for, though, is using it correctly and making sure that it has enough of that crush. So if you're only using like a ½ thick piece of honeycomb for an extremely heavy item, it won't be able to crush before it just gives out and flattens. And that's where I've seen a lot of the folks go wrong. They say, because I'm using a better quality material, I can use way less of it, and then it becomes completely ineffective. So if you would like something, go ahead.
They're for bathroom vanities.
Gotcha.
Mhm.
So that truly depends on where you're putting it for me to be able to identify thickness recommendations.
Uh-huh.
And then it also depends on the purpose. So if the purpose of it is to block and brace, it can be a different density, a different shape, and a different thickness. But if you're using it to elevate like the feet off the ground or to prevent the feet from touching the floor by creating a cushion, that's kind of a different solution, right? So in this case, I couldn't give you pricing. I'm happy to give you supplier recommendations, but the pricing will depend on each shape and each thickness of the individual components of honeycomb that you're looking at.
Yeah, well, we have tops that are highly damageable.
Mm-hmm.
And so it would be to protect that, of course, and the bottom, because the bottom's the most impacted. So, yeah, it would probably have to be, I'm sure, thicker than what you were talking about earlier.
I mean, it really truly depends. I'm happy to have a follow-up call with you if you want to. I'll email you and just we can put some time on the calendar, and I can walk you through. Yeah.
Okay, that sounds good.
For those of you still on the call, I'm answering questions. So recommended packaging for heavy metal items with electronics, cardboard or foam. It depends how heavy. So again, the rule is the heavier you go, the less likely foam is going to be extremely effective for your product over time. So I would have a lot of questions for you. For instance, how long is it in warehousing? How long is it going to be sitting on the foam? So similar to the way that your chairs, like if you're sitting on a chair right now that has a cushion, over time your cushion will wear out and your rear end will start getting sore. So in those cases, the packaging underneath your product is very similar. And so it truly depends. You could have a mixture. I've seen the most successful packs have a mixture of both with, for instance, the bottom of the pack relying on honeycomb or the built-up pads with the corrugate, and having the sides and the corners have the correct foam cushioning, both in density and material. So it might not be one or the other. It just depends on what needs the packaging has to fulfill for what amount of time under what strain. Again, Sienna, I don't know if you're still on the call, but I will reach out to you by email. I'll be the creeper who finds your email in the registration information, and I will send you a conversation starter. And if you want, just send over images or specs of your product, and I'll be able to give you way more pertinent information on that. Mike, you asked some box questions. I like this. How can you check the carton strength of a box? Is it marked somehow? There are ways to check it. So the PSI can be checked based on the weight of the corrugate. So if you cut out like a inch by inch or 3 inch by 3 inch, there's a way to do it so you weigh the corrugate. But unfortunately, a lot of the times, strength is indicated upon manufacturing. So when it comes off the line, day one, when this baby box is born in China or in the US or wherever you're making your box, if it's made out of virgin board, that day it will not have absorbed any moisture. So it's going to be a specific weight and strength. 3 months later, after it's come over the Pacific Ocean, and it's sit in a warehouse in Florida for a while, it's going to absorb a lot more moisture, lose a lot of its structure, but weigh a totally different amount. So, Mike, again, I feel like I'm not answering these questions completely and hitting the nail on the head each time, but the carton strength now, looking at a piece in your warehouse after it's been shipped to you, will always be lower than what they're telling you, unfortunately. And so that's why I say things that are over 75 pounds, the running rule is use 275 PSI double wall boxes, is because by the time it gets shipped to you and stands in your warehouse in storage for that month, 2 months, 6 months, year-long period, depending on how fast your inventory turns, every month that there's moisture, that there's weight and compression and impact to that box and handling, it loses strength. So by the year-long mark, you're probably going to have 100, 150 PSI box from a 275 starter. And that's if you're in a dry area and you haven't beat up that thing to oblivion. So not saying that you do in your warehouse, but depending on what materials you have inside the box, how much weight you're putting on it, and what you're handling it with, also bears weight onto what that strength will be now. In terms of getting what you're paying for, I would just hound your factories and have them confirm. There's a way to check the stamp on the bottom of the box. It is not a required standard internationally, so you don't have, like, manufacturers in China do not have to stamp their boxes. The U.S. does. But if you look at the bottom of your boxes, if they're made in a plant from the U.S., they'll actually have a BMC label, which is a box maker certificate, and it'll tell you what strength it is. If you don't know how to read that, let me know. I can help you through it. If you have a box coming from overseas, they're not required to put that information on there. And to me, at that point, I would say that's when you give me a sample, you mail me a sample, and I can tell you what it is, and you can tell me what it's supposed to be. But there isn't a much better way of doing it after a lot of wear and tear on the box. Any more questions? You're welcome, Mike. It's been an honor. I love talking about packaging. I more so love talking to people who love listening about packaging, so I hope this wasn't too much information for everyone. If you have any questions, please email me. I, again, love to talk about packaging. I'd have to say, let's do the packaging thing again. I'd love to be able to give more information to you guys, so any questions you have, let's have a follow-up call. And I invite everyone who's still on the line, please return in 20 minutes. And join us for the flat pack versus assembly conversation. It's a little bit more supply chain and customer based, so definitely not as much packaging information. So you'll get a little reprieve from that technical side of things. So with that being said, thanks so much. Have a wonderful day. Hope to see your lovely attendance names by within 21 minutes. Bye, everyone.